Hello guys, hope you're having a fabulous day and welcome back to Drantrix, and in this video we are gonna talk about Citrix PVS boot process. Let's get started. So the complete Citrix PVS Logon process and the streaming contains 5 stages. First one is IP acquisition and getting and downloading the Bootstrap file, and PVS Logon process, single read mode, and finally BNI stack and multiple IO mode. So the first thing, the IP acquisition. So the first thing is the target device IP acquisition from DHCP. So initially when the target device boots up, the first thing it will do is to acquire an IP address from DHCP using the DORA process, which is discover, offer, request and acknowledgement. So the first thing, the target device broadcasts the DHCP discover packets. The DHCP server will send a DHCP offer packet to the target device with the following information such as IP address, subnet mask, default gateway, DNS server name and release time. And the target device will send a message to the DHCP server requesting the offered IP address along with the other information mentioned below. And then the target device will send a broadcast message to other DHCP servers telling them that the offer from another DHCP server was accepted. And as an acknowledgement, DHCP server will send a DHCP ACK to the target device. So that's where the IP acquisition from DHCP gets over. And when it comes to the second stage, I have put it in the two parts. One is getting the Bootstrap file and the second stage will be downloading the Bootstrap file. So before we go into that further, let's talk about what is Bootstrap file in the first place. So the target device needs certain information to start the communication with the PVS server in order to stream the vdisk. And that information is provided by the Bootstrap file, and the Bootstrap file name is ardbp32.bin, which will be downloaded using the TFTP server. Hope you guys understand what Bootstrap file is gonna do and why it is important. And here comes the network booting in PVS. So there are different types of network booting, and let's see how getting the Bootstrap file is diverse from each one of these methods. So the first one, network booting with the DHCP options. So just like the DORA process, the target device broadcasts the DHCP discover packets, but in the second stage where the DHCP server will send the DHCP offer packet to the target device with the usual information, but along with those usual information, the TFTP server name and the Bootstrap file name also be provided to the target device. So as you can see, the TFTP server name will be mentioned in the DHCP scope option 66, and the Bootstrap file name, which is ardbp32.bin, will be mentioned in the DHCP scope option 67. So the third thing, as usual, the target device will send a message to the DHCP server requesting the offered IP address along with those information, and then target device will send a notification to all the other DHCP servers that telling them it already got the IP address. So target device gets the DHCP ACK back from the DHCP server. So that's where it gets over. And the next one is PXE method of getting the Bootstrap file. So in this method, target device sends DHCP discover packets along with the PXE broadcast by adding the DHCP scope option, which is 60, and that is for a PXE client identifier. And in the second stage, DHCP server will send a DHCP offer packet to the target device with the usual information just like we talked before. And in the third stage, PXE server replies with the TFTP server address and the Bootstrap file name. And in the fourth, the target device sends the request to the TFTP server for the Bootstrap file, and in return, the TFTP server replies with the Bootstrap file name. and the next will be with boot device management, and that too with the static IP. So in this method, a custom Citrix boot ISO is configured with the static IP address, and when the target device needs to download the Bootstrap file, it will just directly get the IP information from the ISO itself. And the next stage, obviously, it will proceed with the Bootstrap file downloading stage. In this method, we also have advantage at the same time disadvantage too. The advantage is the booting time will be decreased, because unlike the traditional booting method like using DHCP or Pixie or TFTP servers, in this method none of them are going to be used, and it will just directly get all the information from the ISO. So that results in lesser booting time. And the downside is we need to create a hell lot of custom ISOs for each target devices though. The next method with boot device management with the dynamic IP. So in this method, PDM is configured for the target device to follow the DORA process to acquire the IP address from the DHCP, and once all the communication is done, then it will proceed with the Bootstrap file downloading stage. So we are done with getting the Bootstrap file, and now let's move on to downloading the Bootstrap file. So downloading the Bootstrap file using DHCP. So the target device downloads the Bootstrap file from the TFTP server, which is mentioned in the DHCP option 66, and the file name ARDBP32 bin mentioned in the 67. And the next one is downloading the Bootstrap file using PDM. So unlike Pixie or DHCP method, when BDM is used, a tsp bdm.bin file will be downloaded instead of ARDBP32. So prior to PVS version 7.x, BDM used to have two stages of boot process. The one is, the previous server location will be hard-coded into the Bootstrap file generated by the BDM, and the rest of the required boot information such as the low-level PVS device drivers will be downloaded from the PVS server using the TFTP that uses the UDP port 6969. And since the starting of 7.x, with the help of Zen-Desktop Setup Wizard, a BDM hard disk partition can be assigned to a VM during the initial deployment stage. So this wouldn't use a two-stage boot process because it already has all the information, including the low-level PVS drivers as well. So that means everything. And I'm sure guys you all know Harvey Specter, I love him. Anyway, out of the topic, let's move on. So the next stage is PVS Logon process. So first one, the target device contacts the PVS server mentioned in the Bootstrap file using the default UDP port, which is 6910 or 6910, you call it anyhow you want. And the PVS server responds with the IP address and the port number to continue the logon process. And next one is login start, and here with the MAC address, the target device identifies itself and will specify the type of logon being requested. And the next will be the PVS server moves the target device from login thread to IO thread, and PVS server replies with all the disk information, client and policy information needed and sent to the target device. And the target device requests the IP address and port number used for the single read mode. And also the target device requests the PVS server to start the IO thread and request information on which vdisk to use. So the login complete stage is here, and the PVS server grants the access for IO operation to the target device, and the additional configuration is also sent specifying the boot device. And the target device requests which vdisk will be streamed, and the PVS server replies with the vdisk information including write cache location if the target device is in standard mode. The single read mode. So after the target device has logged into PVS and directed to a PVS server for streaming, the Bootstrap file will then intercept any request. So here the target device and the PVS server will continue to communicate, exchanging vdisk data until the Windows operating system starts loading the drivers and BNA stack is successfully loaded. And BNA stack and multiple IO is the final stage of the PVS boot process. So during the final phase, the BNA stack driver is loaded and multiple IO begins. So in BNA stack, the target device initiates the handshake with the PVS server stating the BNA stack driver is up. And BNA stack is loaded into memory and takes over for the Bootstrap managing multiple IO communication. So at this point, the following information is exchanged, such as vdisk name, image mode, AD password management option, and write cache type and size, client name, and licensing. So during the multiple IO stage, the target device's operation and rewrite requests occur as follows. So in the typical read request, a single read request packet will be sent from the target device to PVS server, and in response, multiple read reply packets will be sent by the PVS server to the target device. And in the typical write requests, the multiple write request packets will be sent to PVS server by the target device, and in response, the PVS server will give a single write reply confirmation packet. And that's all for today, guys. Hope you have liked the video and hope you have understand all these steps that we've gone through so far. And if you have any queries or comments, just let me know in the comment section below. And if you really like the video, do like it. And if you really want to watch some more Citrix related videos, you can subscribe for my channel. And have a good day. Be safe. Bye bye.